The last function was a relatively familiar function, but this new one here is quite different. It's fairly unfamiliar to us. But we can still differentiate this because now we have a process to be able to differentiate these implicit functions. And we're going to differentiate these by differentiating y as an embedded function. And so we're going to apply chain rule here. So looking at this expression, I'm just going to differentiate this normally. Okay, so I'm just going to go 5y to the power of 4. But because I differentiated y as an inside function, I just have to remember to apply chain rule. So this is a key part. We apply chain rule here. This next part here is a product function because we have an x squared times a y function. So it's a product. So when we differentiate that part, we have to make sure we apply product rule. But we're going to have to apply the chain rule here as well. So first thing is we're going to differentiate the x squared normally. This becomes 2x. The other function is y, so we just leave that alone, plus x squared. And when we differentiate the y, we now apply the y prime to it. So in those brackets represents the product rule for x squared times y. Then we just differentiate this next term normally. It becomes 4x. And differentiating -1, constants differentiate to 0. So we just need to rearrange this expression. And we're going to group, what we want to do is solve for y prime. So we actually have an expression that we can calculate slope with. But we want to make this a little bit nicer. We want to solve for y prime. So that's what I'm going to do. I'm going to group together my y prime terms. So I'm going to have 5y to the power of 4. Actually, I'm just going to keep that in black because really I'm just now interested in the y prime. So there's my y prime plus 2xy plus x squared. Again, there's another y prime term minus 4x. And I want to put everything onto the right-hand side that doesn't have a y prime term. And I'm going to keep the y prime terms together. So I get 5y. I'm going to factor this y prime out to group them together. So I have plus x squared y prime, and then everything else goes to the other side. So this does not have a y prime term. This doesn't have a y prime term. So those are going to all end up on the other side. 4x minus 2xy. Okay, so that represents those terms. I'm going to factor the y prime out because I want to solve for y prime. So I get y prime 5y plus x squared, and that's going to be equal to the 4x minus 2xy. So then finally, I just solve for y prime. My y prime, now this becomes a function of x and y. So on the other side, there are x's and y's. So my implicit derivative, I'm just going to finish this off here, 2xy, all divided by 5y plus x squared. Okay, so this is my implicit derivative here. Okay, and this is now an implicit function. So the implicit derivative, this is an implicit derivative, meaning I need both x and y coordinates. Okay, so now the nice thing about this problem is, well, we've been given the x and y coordinates. So if I want to now calculate the y prime value or the slope, I want to find the slope when x is root 2 and y is 1. That's what I'm looking for. I want to know the slope at this point here. Okay, so then what I'm going to do is I'm going to plug in to my expression x is root 2 and y is 1. So minus 2, there's another x, so root 2, and times y is 1. So basically, wherever I see my x and y's, I'm going to plug those values in. And in the denominator, I get 5 times y. Y is equal to 1 plus root 2, and that's going to be all squared. So I can calculate the slope here. The slope works out to be, when I simplify the numerator, I end up with 4 root 2's minus 2 root 2's. So that's going to be 2 root 2 in the numerator. And in the denominator, I get 5 plus root 2 squared is 2. So I get 5 plus 2 is 7. So the slope is 2 root 2 over 7. Now that works out to be approximately 0.4 on my calculator. So looking at the graph here, what we're saying is that we have a 0.4 slope tangent line that goes through there. Okay, that looks about right. So on our Desmos, we're going to check this out, but we want to do this a little bit more accurately. So we're actually going to graph the tangent line. To do this, we're going to use a point slope form. So using the point slope form of the equation, we get y is equal to, the slope is 2 root 2 over 7. And the point that we're going to use is x is root 2 and y is 1. So we get plus 1. And this is going to be the tangent line equation that we're going to graph. And when we graph this, we expect it to be the same as that green tangent line that I've drawn in this picture.